Hi, we from Group 1. We would like to present question 1.
Hi, my name is Wani Hazika binti Rozani. Matrix number is 33DPE21F1058.
Hi, my name is Shina Miftahul Haroma binti Sukardi. My number matrix is 33DPE21F1044.
My name is Nurul Shazwadi binti Zaidin. Nometric 33DPE21F1045.
Today, I want to intro about differentiations. The derivative is defined as the rate of change one of quantity with respect to another. In terms of function, the rate of change of function is defined as d1 for dx or f for the x.
The concept of derivative has been used in small scale and large scale. The concept of derivative used in many ways, such as change of temperature or rate of change of shapes and size of an object depending on the condition.
For example, to check the rate of change of the volume of a cube with respect to its decreasing size, we can use the derivative form as dy over dx, where dy represents the rate of change of volume of cube and dx represents the change of size of the cube. There are many applications of differentiation in our real life. For example, to find the range of magnitudes of the earthquake. Second, to calculate the profit and loss in business using graph.
To check the temperature variation, to determine the speed or distance covered, such as mil per hour and km per hours.
Number 5. Derivatives are used to derive many equations in physics. Number 6. To determine the maximum and minimum values of particular function.
So, from the set 1, we got question. A metal rod of length 4.5x cm expands when heated through 200 Celsius. After T seconds, the radius of the rod is x cm. The cross-sectional area of the rod is increasing at a constant rate of 5 cm square per second. So from the question, we got that the height is 4.5x cm and dA per dt equals to 5 cm square per second, and the radius is x cm. So the rod is cylinder, so we need to use formula of cylinder.
This is a drawing that I draw in the middle of the cylinder. The cross-sectional area and height is 4.5x cm.
For question 2, we need to find the dx per dt when the radius of the rod is 3 cm. So, first from the question it states that the cross-sectional area of the rod is increasing at a constant rate of 5 cm square per second. So, it is dA per dt equal 5 cm square per second. We can use formula A equal pi r square. So, A equal pi r square, let r equal x. A equal pi x square. When differentiate, it will become dA over dx equal to pi x. So, it will become dA over dx equal 5 cm square per second. The question needs us to find dx per dt. So, dx per dt equal dx per dA times dA per dt. We got dA per dx as 2 pi x. So, if we need to use dx per dA, it will become 1 over 2 pi x. So, 1 over 2 pi x times 5. So, we get 5 over 2 pi x. When radius equal 3, so we replace x with 3. Then it will become 5 over 2 pi 3. So we got 5 over 6 pi. So the answer is 0.265 cm square per second. We take 3 significant figures.
For question 3, we need to find the rate of change of the volume of the rod when x equals to 3 cm. So, we need to find dV over dt. So first, we need to use the formula of volume of cylinder because the rod is cylinder. So we use V equals to pi r square h. First, we need to let r as x, so it will become V equals to pi x square h. So, from the question, it's written that the length of metal rod is 4.5 cm. So we have the height of the cylinder. So we just put the 4.5x into the formula. So it will become V equals to pi x square times 4.5x. So it will become 4.5 pi x cubed. So we need to differentiate 4.5 pi x cubed. So it will become dV over dx equals to 4.5 times 3 equals to 13.5 pi x 3 minus 1 equals to 2. So 13.5 pi x square. Then we need to find dV over dt. To find dV over dt, dV over dx times dx over dt. We already have dV over dx, and we already have dx over dt from the question 2. So for dV over dx, 13.5 pi x square times 5 over 2 pi x. 5 over 2 pi x we got from the question 2. So when x equal to 3 cm, we just put the 3 into the x. So it will become 13.5 pi 3 square times 5 over 2 pi times 3 because the x we already replaced with 3. So it will become 121.5 pi times 5 over 6 pi. So when we put in the calculator and we solve it, it will become 101.25 cm cube.
In conclusion, differentiation is a method of finding the derivative of a function. Differentiation is a process in methods when we find the instantaneous rate of change in function based on one of its variable. List of differentiation formula as the following: product rules, quotient rules, and chain rules.
That's all from us. Thank you.